Hello students, in this episode we will try to learn a little more about standard deviation. Actually, to understand standard deviation we must also know about mean deviation, variance and then standard deviation. So, we will try to understand about these measures. Now, why we are trying to understand all these things is that many people feel that if we are going to calculate these with the help of a computer, we do not need to know anything about these numbers or the methods. We just apply the computers and apply the numbers into the computers and then get our results. But for a researcher, it is very important to know about the tool itself and what are the implications of the tool what are the implications of the formula, the tool that you are going to use and how it should be interpreted. And this is why we have been trying to understand about these different measures, central tendencies and then also trying to now understand about mean deviation, variance and standard deviation. Now, for mean deviation, the formula is x bar minus xi or xi minus x bar, anything we can put it as anything, by n. So, we have to find out x bar minus xi and sum up all these x bar minus xi's. So, summation of x bar minus xi's divided by n will give us the deviation from the mean. By saying that we are trying to find out the deviation from the mean, we are trying to see how far away each of these scores lie from the mean. So, distance from the mean is being calculated here, and suppose we take an example, maybe we can understand with the help of an example in more clear terms. And so, suppose the data set is 6, 10, 5, 4, 9 and 8 as seen on your screen, and if you add up these you get 42, and since there are 6 scores, 6 numbers in the data set, divided by 6 you will get 7. 7 is the average or it's the mean. Now, we want to see each of these numbers how far apart they are from the mean, and so xi minus x bar or x bar minus I, but now we will take xi minus x bar for our example, and xi represents each of the score. I can take the value of 1, it can take the value of 2, it can take the value of 3. For the first number x1 will be 6 and x2 will be 10 for example. So, I takes the values of the first number and second number or third number as the case may be. And so, if we take these as x bar minus xi, first number is 6, 6 minus 7 will be the first deviation. The second number would be 10 minus 7 and so on. The next number would be 5 minus 7, 4 minus 7, 9 minus 7 and 8 minus 7. So, what we are doing here is we have the data set, and from each of those in the data we are subtracting 7 to find out how far away this number is from the mean. Mean is 7. And absolute deviation, if you want to find out the absolute deviation, that means deviation in absolute terms, then you will find 6 minus 7 is equal to minus 1, 10 minus 7 is equal to 3, 5 minus 7 is equal to minus 2, and 4 minus 7 is equal to minus 3, 9 minus 7 is equal to 2, 8 minus 7 is equal to 1. So, if you look at it actually, what you will find is that the pluses and the minuses cancel out and the deviations from the mean will be equal to 0. So, if you find out the mean deviation using the exact mean, in other words subtracting from the numbers, each of the numbers the mean, and then you look at those absolute values that you get and you add them up, then you will get 0. Here, what are the steps that we have followed? We have first of all computed the average. By adding up all those numbers, we found out the total and divided by 6 and we got the average. Then the second step was, so xi minus x bar, where I takes values 1, 2, 3, 4. And so we have found out the absolute deviations. And we saw that some of those deviations were minus in sign and some were positive. When we sum up these absolute deviations, then we get 0. The sum of the absolute deviations will be equal to 0. So why we have calculated the average initially was that this is needed, the mean is needed to calculate the mean deviation. So you need the average to calculate the mean deviation. That is why we have taken it, because the formula is what? The formula is summation of x I minus x bar divided by n. So this is what we had to find out. So if you look at the table, you will see that the absolute deviations, when you find out the deviations actually, you should ignore the signs, otherwise you will get 0. So you ignore the signs. If you ignore the signs, then you get the total equal to 12. If you divide that by 6, because there are 6 observations, so if you divide it by 6, then you get 2. What is this 2? 2 is the average deviations from the mean. On an average, each of the variables is 2 units away. So this is how we try to interpret this. And sometimes there are some problems with this. On an average, each observation is 2 units away from the mean in this example, but there are certain problems. It is not so easy actually. In mathematics, when the numbers are given as discrete numbers, there are some problems, and it is difficult to manipulate these numbers algebraically. And so some difficulties that you find when you have discrete numbers. These absolute values cause enormous problems for even when you are using calculus also. Calculus can be used when there is continuous data, and this data is discontinuous. Between 1 and 2 there is no other value. So you find 1, 2, 3, 4, so you have discrete numbers. But for calculus you need to have continuous data. So these problems arise when you have discrete data. So we need to know something else also. So what we try to do is we try to find out the variance and the standard deviation in this case. So instead of taking the absolute values, because they have pluses and minuses signs and they cause some problem. So what we do is we square those deviations. Minus into minus will become plus, and plus into plus will anyway be plus. So if you take the squares of those deviations, then to some extent we can overcome this problem. So instead of taking these absolute values, we take the squares of these deviations from the mean, and these yield a positive value. This will result in measures we call the variance and the standard deviation. Now, any of these things can be found out for a sample, they can be found out for a population, just as we had seen earlier that the arithmetic mean, median and mode can be found out for a sample, and also they can be found out for a population. So in this case also standard deviation can be found out for a sample, they can also be found out for a population. Now when it is found out for a sample, then it is denoted by S. So standard deviation can be symbolized S when it refers to a sample, and the square of this standard deviation will give us the variance. In the same manner, for a population also you can estimate standard deviation. So you use sigma for standard deviation. When you are finding out the standard deviation of a population, it is represented by the symbol sigma, and sigma square will give us the variance. So these two measures are very important, and they help us to overcome the problem when we take mean deviation. So how do you calculate the variance? It is simple. Once you know how to calculate the mean deviation, it is very simple for us to calculate the variance. And once you know the variance, from variance we can derive what is known as the standard deviation also. So, the formula for variance, this formula is S square, which is nothing but the summation of x bar minus xi whole square, or you can also write it as xi minus x bar whole square divided by n. So, if you use this formula, you can find out the variance. Once you know the variance, the square root of the variance will be the standard deviation. S, that is the standard deviation of a sample, would be equal to square root of summation of xi minus x bar or x bar minus xi, you can take anything, whole square divided by n. Now, to understand this further in a better manner, let us take an example. And so, suppose the data set is 6, 10, 5, 4, 9 and 8 as seen on your screen, and if you add up these, you get 42, and since there are 6 scores, 6 numbers in the data set, divided by 6 you will get 7. 7 is the average, or it's the mean. So, we have 3 columns in the table. The first column is x itself, the numbers that you have. So, 6, 10, 5, 4, 9, 8, these are the numbers that are found under x or in column x. And then you have x minus x bar, which is 6 minus 7, 10 minus 7, because we had seen that the average is the mean. X bar stands for the mean. The mean was 7. So, 6 minus 7, 10 minus 7, 5 minus 7, 4 minus 7 and so on. Then we get x minus x bar, which we can calculate and see. We get, if we see the numbers, some have negative numbers and some have positive. So, the first one is minus 1, then 3, then minus 2, then minus 3, and then 2 and 1. And so, if you add these up, they would be equal to 0. So, to overcome this problem, what we do is we find out the squares of these numbers. These numbers are nothing but the deviations. If you square the deviations, then you get 1, because 1 square is equal to 1, 3 square is equal to 9, 2 square is equal to 4, 3 square is equal to 9, 2 square is equal to 4, and 1 square is equal to 1. So, x minus x bar whole square, x minus x bar whole square. So, these are the squares of the deviations from the mean. And if you look at it, then again you will find that the total number of all the numbers added up together would be, the total would be 42. And so, if you add up this x minus x bar whole square, then you would have 28. The sum would be 28. The sum of x minus x bar whole square will be equal to 28. Now, we can apply the formula. Suppose we want to find out the average. You can see on the screen there, average is x bar. X bar is equal to sum of x divided by n. X are the numbers that you see on your screen, the scores that we have calculated the variance for. The scores are 6, 10, 5, 4, 9 and 8. And so, summation of x, what did we find? Summation of x is 42. 42 divided by n. So, n is number of observations, those are 6. And so, 42 divided by 6 will give us the average 7. Now, if you want to find out the variance, then variance is S square, variance of a sample. S square is equal to sum of x minus x bar, xi minus x bar whole square divided by n. We can see that the sum of x minus x bar whole square is equal to 28. So, substituting this value, 28 by n is equal to 6, 28 by 6, you get 4.67. So, the variance from the mean is 4.67. So, this is how we calculate the variance of some numbers which are a part of which are a sample actually. Now, for the same sample, suppose you want to find out the standard deviation, then as you have seen earlier, root of s square will be the variance. So, in other words, variance is 4.67. So, root of 4.67 will give us the standard deviation, and if you calculate it, you will get 2.16. So, 2.16 is the standard deviation of the scores that we have noticed earlier. Now, to summarize what we have learned today, we had seen that you will not be able to know about the numbers. So, in addition to this, we need to know a little more about these numbers. So, it is there that we try to estimate the mean, and we try to find out the variance, and with the help of that also we may try to find out the standard deviation. So, we try to see how the deviation, mean deviations are found, and then on that basis we try to find out, we came to know that the squares of the sum of the squares of the deviations from the means divided by n will give us the variance. So, if you take the squares, the sum of the squares of these deviations divided by the mean would give us the variance. So, we had tried to estimate variance, and then again we found out that or we were told that the standard deviation is nothing but the square root of the mean. So, we tried to find out the standard deviation, which is the square root of the mean. Now, what does this standard deviation give us? Standard deviation gives us the fluctuations that occur in the numbers. So, standard deviation will tell us approximately how much of fluctuation, whether there is a very huge amount of fluctuation in the numbers from the mean when you find out the deviations. Do you find lots of fluctuations from the mean, large fluctuations or smaller fluctuations? As you know, when you try to interpret about the numbers, or when you try to see a representative number or try to predict on the basis of these numbers, we would prefer the numbers to be closely located to the mean. But if there is a huge amount of deviation, the standard deviation shows us whether the deviations are very wide or whether they are not so wide. And naturally we would prefer numbers, or we would have better predictability when the standard deviation is lower. And if the standard deviation is higher, then such numbers cannot be dealt easily, because your predictive capacity would not be so high. So, the ability to predict with numbers which have high standard deviation would be very low, and we would prefer them to be with smaller standard deviation. So, this is what we have learnt through these series of lessons, and now we are ready to apply this to computers. And so, first we would have to understand about the computer packages or the particular package that we are going to apply ourselves to, and then we can try to see how these are found with the help of a computer. Now, let us take down some questions. Explain the need for additional information after finding out the central tendencies. The second question is, explain the difference between variance from the mean and standard deviation. The third question is, why is standard deviation known to be a very important indicator whether our predictions about a set of data will be true or not? The books that you could refer are the reference books provided by the UGC. One more book, so Business Statistics by J.K. Sharma, published by Pearson.